Welcome to clickmyproject.com.
Now we discuss about novel intervaled bidirectional Snubberless soft switching current feed full bridge voltage doubler for fuel cell vehicle. During the developing world, the eco-friendly and renewable energy source based energy generating system will be used for vehicle movement. In our proposed, we use the fuel cell for vehicle movement. Here, our vehicle will be movement will be the high amount of torque. The high amount of torque or rotation speed will be generated by the high voltage AC or DC motors. In our proposed, we use the DC motor for developing the high torque for the wheel. In our proposed method, we use the fuel cell for give the speed for the motors. Here the motors will be torque the high amount of we want the high voltage, but the fuel cell will be generate the low amount of voltage. So in our process we use the full bridge voltage doubler Snubberless current transformer will be used for energy storage system. Here the inverter will be used to boost the fuel cell output voltage in for maintain the running in the motor. Here the fuel cell will be getting the 12 volt, and then we use the full bridge with the two input. Here we use the 8 switches. Each full bridge will be getting 4 switches, and the IGBT switches will be used to reduce the current loss or the voltage loss, and also the ZPS concept will be remove the or low level losses for maintain the output voltage. Here the 12 voltage will be given to the converter, and the converter invert the DC voltage into AC voltage. After it will go to the transformer, and the transformer boosts the voltage and it will be generate the current. Here the DC to DC conversion, the current will be boosted, and the boosting current will be getting into the induction motor, and then the induction motor ran at the particular level. Here the induction motor getting the nearest to 380 voltage for the process. In our proposed method, the ZPS concept reduce the conduction loss in the switches. Here it will be reduced the harmonic in the output voltage. So the output voltage will be getting the low harmonic and the high level input outputs, and it will be generated based on the normal DC-DC converter, and the fuel cell will be generate the output voltage. The fuel cell will be run by using the hydrogen tank, and then it fuel cell generate the voltage, and it will be go to the converter, and the converter convert it to and at same time it will boost the DC voltage from 12 volt to 380 volt, and that 380 volt battery will be getting into the induction motor. Then the induction motor ran. Here the fuel cell will be generate the sufficient amount of voltage like 380 volt. Now the converter will be switched off, and it will be shut down the battery to motor device. Here the battery will be the initial stage, so that the initial stage the converter only be used for the process. It is the flow diagram for our proposed work. In this flow diagram, first we go to the DC input, and the DC input will be go to the dual half-bridge inverter, and here the half-bridge inverter or the output will be go to the transformer, and the transformer is convert to the DC output. Here the both switches will be controlled by the pulse width modulation technique. The pulse will be operate whether when the switch will be on, when the switch will be off. The switch will be on and off condition based. The DC current will be converted to the AC current, and the AC current only allowed to the transformer. The transformer boosts the current, and it will automatically convert to the DC current. Here we use the capacitors and also any other device for maintain the voltage from the output side. After we go to see our Simulink model. In our Simulink model, we use two full hybrid circuit or inverter. Here we use the DC to DC converter for boost the input voltage to high of output voltage. Here we use the DC source for generate the voltage, and the DC volt will be connected to the capacitor and also to inductor. The capacitor and the inductor will be remove any noises is there in the DC output, it will be removed. After then we will give the input of the two full bridge with 8 switching inverters, and that two fuel bridge will be interconnected both in the output voltage, and both will be generated the each amount of voltage, because that is not possible to build the 12 voltage to 380 voltage of output. In that reasons we use the 12 full bridge for improve the output voltage at desired level. Here each full bridge will be getting 4 switches. The MOSFET switches will be used to convert the DC input to the AC input, and here the capacitor will be added in the both full bridge. The capacitor will help to reduce the harmonic in the output AC, and that the AC will be going through the inductor, and that inductor will be remove any harmonics in the AC, and it will be give the pure AC to the transformer. Here the transformer will be the step up transformer, so the 1:n ratio transformer will be used. The step up transformer step up the input voltage in the both sides, because the two full bridge inverters getting the same level voltage, so that reason the output will be bolted as the partially compared to the output. If the output will be 300 voltage, then the each full bridge inverter will be generate the 150 volt and 150 volt output, and that output will be going to the another two switches. Here that inverter will be invert the AC current of output transformer is converted to the DC output. Here two capacitor will be used for charging and discharging purpose, because during the AC to DC conversion, the first positive half cycle the DC will be getting the current, the negative half cycle the DC does not get the current. So that reason the capacitor will be getting the current will be charging, and the capacitor does not giving the current, it will be discharging the voltage for giving the output. So the output voltage will be maintained at the 380 volt. Here we use the AC conversion is possible for, because the transformer only allow the AC current, so the output will be came at the low harmonic, because the PWM generator will be generate the pulses with desired level, and it maintain the output voltage. In future we use a controller for maintain the output voltage at desired level. Thank you.